Here is the uncomfortable truth. The biggest AI model is often the wrong engineering choice.
Right. Bigger models can do more, but that does not mean they should do your job. For most programmers, the real question is not which model is smartest. It is which model creates the best product.
And that sounds backwards, because the internet keeps telling people that more parameters means more power, and more power means better.
Better at some tasks, yes. Better for your app? Not always. You are trading capability against cost, latency, reliability, and how often users can actually hit the feature.
So this is not a philosophy debate. This is architecture, budget, and user experience.
Exactly. If you are new to AI, think of small models as cheaper and faster, and large models as more capable, but more expensive and slower. That trade-off shapes almost everything.
Give me a concrete case. A programmer is building a support tool. When does the small model win?
If the tool is classifying tickets, extracting order numbers, routing issues, or drafting short replies from a tight template, a small model often wins. The task is narrow. Speed matters, volume matters even more.
Because every support ticket becomes a bill.
Yes, and also a wait. If your model takes too long, agents stop trusting it. If it costs too much, finance kills it. A slightly less capable model that answers in half a second can beat a brilliant one that takes 5.
So latency is not just a technical metric. It changes behavior.
Completely. Users forgive an answer that is 85% useful if it lands instantly and fits the workflow. They do not forgive a perfect answer that arrives after they have already moved on.
Now, flip it. When does paying for the larger model become the smart move?
When the task needs broader reasoning, better instruction following, stronger writing quality, or more resilience on messy inputs. Think debugging a weird stack trace, summarizing a long technical document, or generating a careful migration plan.
So the larger model earns its keep when ambiguity is high.
That is a good rule of thumb. The more open-ended the task, the more edge cases you have, and the more expensive mistakes become, the more a larger model starts to justify itself.
Give me another scenario. Let us say I am shipping an AI coding assistant inside an IDE.
Then you probably want both. For fast autocomplete or simple refactors, a small model is ideal because latency is everything. For harder requests like explain this bug, redesign this function, or write tests from a messy file, route to a larger model.
That sounds like the hidden answer is not small versus large. It is orchestration.
Exactly. A lot of winning systems use a cheap, fast model for the common path, and a stronger model only when the task crosses a difficulty threshold. That is how you control cost without dumbing down the product.
And if you do not think about that, what happens?
You get trapped. Teams launch a flashy demo on a large model, then discover the unit economics are terrible. Or they over-optimize for cost, choose a tiny model, and users quietly stop using the feature because the answers feel brittle.
So the losers are the teams that confuse benchmark scores with product fit.
Yes, benchmarks matter, but your actual task matters more. A model that is incredible at broad reasoning may still be the wrong choice for high-volume extraction. And a small model that is great at routine tasks may fail badly when the prompt gets messy.
Let us make this painfully practical. I am a solo developer with a limited budget. What should I choose first?
Start with the smallest model that can clear the quality bar for your real users. Not your dream users. Real users, real prompts, real failure cases. Then move up only if capability unlocks something your customers will notice and pay for.
And if I am building for internal ops, where scale is huge, but mistakes are tolerable?
Bias towards smaller models. They shine in repetitive workflows, tagging logs, cleaning text, extracting fields, routing requests. The savings compound fast, and lower latency makes the system feel invisible, which is often exactly what internal tools need.
But if I am building a premium feature where one great answer can save an engineer an hour?
Then the larger model can be a strategic weapon. If higher capability clearly creates better decisions, fewer mistakes, or a dramatically better user outcome, the higher cost is not waste. It is leverage.
So, the question is not, which model is best? It is, Where does intelligence create enough value to deserve its price and delay?
Exactly. Small models win when speed, scale, and cost dominate. Large models win when reasoning, nuance, and error reduction dominate. The teams that understand that split will ship faster, spend less, and build products people actually keep using.